If the VIGV operating sequence requires a greater variable inlet guide vane angle, the control system will shift the spool valve of the IGV servo valve to a position which allows hydraulic fluid to flow to the upper section of the hydraulic cylinder. Hydraulic fluid from the lower section of the hydraulic cylinder is dumped to drain. The actuating arm of the hydraulic cylinder retracts and rotates the inlet guide vane ring counterclockwise, turning the variable inlet guide vanes to a greater angle. If the VIGV operating sequence requires a smaller variable inlet guide vane angle, the control system will shift the spool valve of the IGV servo valve to a position which allows hydraulic fluid to flow to the lower section of the hydraulic cylinder. Hydraulic fluid from the upper section of the hydraulic cylinder is dumped to drain. The actuating arm of the hydraulic cylinder extends and rotates the inlet guide vane ring clockwise, turning the variable inlet guide vanes to a smaller angle. The core of each LVDT moves as the angular position of the variable inlet guide vanes changes. This provides feedback to the control system concerning the actual VIGV angle. When the commanded IGV angle and the actual IGV angle are the same, the control system resets the IGV servo valve to its null position. Actuation of the inlet guide vane ring by the hydraulic cylinder pivots the guide vanes about their mounts and increases or decreases the effective inlet area of the compressor. As the actuating arm of the hydraulic cylinder retracts, the variable inlet guide vanes open. As the actuating arm of the hydraulic cylinder extends, the variable inlet guide vanes close. This voltage is linearly proportional to the position of the hydraulic cylinder. The LVDT core moves as the actuating arm of the hydraulic cylinder moves, varying the feedback voltage. During startup of the gas turbine, the control system energizes the IGV solenoid valve 20TV-1, allowing trip oil to actuate the IGV dump valve VH3-1. This enables the IGV servo valve 90TV-1 to direct hydraulic fluid to the lower section of the IGV hydraulic cylinder. The actuating arm of the hydraulic cylinder keeps the variable inlet guide vanes in their closed position. At about 85% corrected speed, the control system causes the IGV servo valve 90TV-1 to direct hydraulic fluid to the upper port of the IGV hydraulic cylinder. The actuating arm of the hydraulic cylinder retracts and rotates the inlet guide vane ring counterclockwise until the inlet guide vanes open to their minimum full speed angle. When the set point temperature is achieved, the control system causes the IGV servo valve 90TV-1 to increase the flow of hydraulic fluid to the upper port of the IGV hydraulic cylinder. The actuating arm of the hydraulic cylinder retracts and rotates the inlet guide vane ring counterclockwise until the variable inlet guide vanes open to their full open position. This allows maximum airflow through the axial compressor. When the set point temperature has been achieved, the control system modulates the position of the variable inlet guide vanes in accordance with the sequence control defined in the control specifications. In general, the IGVs begin to open from the minimum full speed angle as the exhaust gas temperature approaches the base temperature limit and will achieve their full open position at the base temperature control set point, about 1000 degrees Fahrenheit. When the lead operator selects Stop and Execute on the operator interface of the turbine control panel, the unit will begin the unloading sequence. Fuel flow to the turbine is reduced and exhaust gas temperature gradually decreases. At the appropriate exhaust gas temperature set point, defined in the control specifications, the inlet guide vanes will close to the minimum full speed angle. When the load is low enough to trip the reverse power relay, the generator breaker opens and the shutdown sequence continues. As the unit decelerates from full speed no load, the inlet guide vanes are gradually closed. The turbine protection circuits are designed to sense any abnormal operating conditions such as loss of flame, overspeed, overtemperature, high vibration, or high exhaust gas temperature spread. When any of these conditions exist, the control system will initiate a trip by de-energizing the IGV solenoid valve 20 TV-1. Trip oil is then dumped to drain, and the spring in the IGV dump valve forces its spool valve to the trip position. The IGV dump valve bypasses 90 TV-1 and directs the flow of hydraulic fluid to the lower section of the hydraulic cylinder. The upper section of the hydraulic cylinder is connected to drain. The actuating arm of the hydraulic cylinder extends, rapidly closing the variable inlet guide vanes.